think we are live. Don't need you. We don't need you. Excellent conditions. Think we are live. A little bit behind, but yes, I'm going to call that live. Come back to another streaming session. Of course, much later than I expected, so I won't be making any promises. That stuff. We've moved over to C-Line. We should call that live. We've moved to C-Line by Telechat. Come back to another fully licensed. I got fed up with Emacs. Not particularly because Emacs is bad. Because if I plug in, I can't figure out how to configure, and it just puts tons of. Get rid of that for you. Puts tons of syntactic clutter all over the place, telling me all sorts of things I don't actually want to know. I don't know why. I'm on Ubuntu, and I do not know why it flashes when I bring this over, hide it there, and on the live stream it seems to flash up sometimes. Nope, don't know why. Right, let me put that over there for now. Kill the stream like that because I've got a feeling others are using the internet. Student recommended. Widget. Stream's healthy. No, it's not. We recommend use a stream rate of 4,000 kilohertz. If it's bad quality, never mind. So where are we at? I did a little bit off stream. I said I wouldn't, but I couldn't resist. I was kicking around for half an hour. Sorted out. So we were in the process of writing Alexa. These are all the lexical tokens. We called ML type. All the types of tokens. And then we have the actual token, which we seem to have called LTOC. So let's rename that to token. What do we do in Visual Studio? Not Visual Studio. C-Line. C-Line is awesome. Here it is. Token type. There we go. So we have lexical tokens. We call them token type, which fits in with our variable naming. The most important thing is we're not worried about performance, so that means when we match something, like a number, we scan through it, we get the length of the scan, and then I create a string from it. So probably an allocation going on there, maybe not. I assume Rust has got a small buffer allocator. Optimization. I don't know for sure because I do not know that much about Rust. Let's walk through what's going on here. Chars is our iterator. They're not super flexible, particularly this one, so I don't think you can go back. Clone is make a copy of it, which I think is lightweight. And then while we have some characters left, I won't listen to music, but it looks like I'm talking a bit. While we have some characters left in the iterator, let's keep iterating over them. And then if it's not an ASCII digit, I'm not worried about other digits, then we break out. So the moment it's not a digit, we break out, and if it's at the end of the thing, we break out. Probably want to do some error checking here to say if you've hit the end. Yeah, no, I don't know. No. Don't need any error checking. So what we have is we have a range between start and chars, which is the current iterator. You know what? Let's call that So chars is at the start, iter is 1 past the last digit, which could be our end. Then we work out the length. So to do that we use astra, which gives us the string slice effectively, a pointer and a size, from the start position to the end. So whatever it is, that's pretty cheap to work out. And then we get the length of it. We then so we make a clone of start. That is going to point to the number 1. That's where start is. And as we go along, we keep going through this while loop above us, and we get all the way to here. We go 1 past the end, and that is where our iter lives. We then get the length of them. So that's from here to here. Because when we get the length, when we convert start into a str, we get that back. We convert that into a str, we get that back. So the length gives us the delta, which contains the number. It took me a while to figure this out while I'm in Rust, because I just wanted to do a difference between the two iterators, but they wouldn't let me. And I'm sure if I dropped into unsafe I could. If there's a better way, let me know. Okay, so once we got that, I called it number. We convert it, get the start as a str to the length, which gives us this bit, and then we convert it to a string just to get outside of the source string, so we can forget about the source string later on. Ideally what we'd do is once we've got that number as a string, we would maybe put it in some subsystem that converts strings to identifiers or pointers or whatever we want them to be, so we can do easy comparison between strings just by looking at an ID. Not important for numbers, important for identifiers and other things. That's our string, it uses the same technique. Not happy about that, but what to do is sort the error messages out another time. We're not trying to build a robust thing here, we're just trying to mess around and write some code. Okay, we've got some tokens. No, what am I saying? Follows the same principle, just with different break characters and that panic there. Identifiers are A to Z, capital A to Z, and an underscore, that's what they start with. And then any alphanumeric or C equals underscore. And C is not equal to underscore, then we break out, so it's a similar pattern. Then we get the identifier, get the text for it. We do a match to check for keywords, default being an identifier, so we can match our keywords and push them out with a new type. What else is interesting? We've got a token without strings, this is like less than, greater than, commas and so on. Oops. And we suddenly looking for my phone, which I have left somewhere, but where did I put it? Where did I put it? Right, I'm going to have to go and find that. So And we found it. And right, back to what we're thinking about. I'll select type is also something just to make it easy on these things, so it looks one ahead. Doesn't actually peek. Come back to ahead, and if it finds something, we set type appropriately. Overall, pretty clean, pretty slow, I'd imagine. But not worrying about that. So that was a standalone function. It creates a vector of tokens, maybe optional tokens or results token when we get into turning these things. What we want to do now is work on the lexer, so we can create a nice little class that does our thing for us. And, what we really want this to be is str reference. We don't want to hold on to the source, and we don't need that. What we do want to do is have tokenize source. Now I think no, that's okay. I reckon we're going to get some awesome. Oh, that's a problem. Yep, I did mean self dot too much. Cannot be related to that. Okay. Oh, yes. Okay. Huh. Cool. Ooh, we have a bug. We notice that we are, first of all, we're matching a space, and second of all, we've lost the huh. Okay. That's because of this. Equal to we're moving on one, aren't we, before we lose stuff. So start is begin. I don't think we need that. You'll use begin there. Same with this. Begin. We don't want to start there. We're good there, but not good. What am I missing? If it's not enough numeric and not underscore or C is ASCII white space break. I think it's going one too far, isn't it? Which would apply. We need a -1 on here. Got two situations. So one next is failing, which is bringing it out without moving it on. And we have two we know this is the last big one. And we want to do and here. Hello and well, isn't it? So we need to roll that back into the other guys. Should have 4 missing off of it. Nope, we collected the space. Here we go now. That's good. And 1, 2, 3, 4, yes. I'll begin. See, I've got the -1 there, but that's there to counteract this. Which should be wrong if we put the number at the end of the script. Well, 1, 2, 3, 4, 5. Yep, I need a wonder where I am. Muscle memory is not quite there. Incorrect. Helps I work on the right one as well, doesn't it? Here he is. And then we go to here. Clone the this is special. And end is not the pair of start, finish is you start and you finish, you begin and you end. See what we're doing? This is a string. This is not a string. Begin. That's not done all that. Begin is taken before we move to the next character. That doesn't seem right. I'll be pointing at the last one. Should be fine. Yeah, it's working. All is good. Okay, I'm going to ignore that for now. Not really sure what I'm ignoring. Here we go. So we've got printer working. We've got next working. So we print. Needs to be mutable, mutate stating. Next is none. That's not surprising because that's what we need. If self dot was greater than self dot transcend dot len. Some yes, I did need that. Does it have a posting command like that? Hey, you don't have. No. And obviously that's better than equals, which is why you should really use iterators, but I'm trying to avoid as much of the lifetime checker as possible. And storing iterators always seems to get me a little bit confused. The old is not used, which is true. Old. Find out. Now obviously I'm doing string doesn't implement copy apparently. There we go. Whoa. Makes me suspicious. Okay. So we just done made a clone on the token, which means we're not moving it, and we have a string that could allocate, so every single call next could allocate. Do we again? No. Can we fix it? Easy when I tackle lifetimes. For now, I'm just wanting to get something working. We shouldn't ever have to go backwards in our stream. Plus around. What is that? Space match, expected use size. There we go. Cool. Let's write it helps if I split current right as well. Control Z equals in Emacs. Type check for you. Next. Peep. Actually 0, 1. And none. Good. Was that a reset? Zero. Next, reset iterator. Let toke equals next dot next sum and the keys, and then we can do print, and let's just have to call the tokens we have. And finally print all. So hello, 1, 2, 3. Boom, boom. Okay. You're good. Do we want to... No, we don't. We need a parser. Do we need a parser? For parsing. Not sure. Yes, we do. We need a parser. So struct parser. We have a lex, which is a lexer, not a lexer. It is a single lexer, and we can have some other stuff. We'll sort that out in a minute. No self. And we do lex. Parser equals is. Okay. Where are we at? Undeclared use of parser. Yes, undeclared use of parser. Because you need to be capital. Okay, lots of warnings, not worried about those. Let's get rid of all that. Now, how do I make that mutable? We don't need to, we just send it everywhere mutable, don't we? Right. And the only thing in here is fn expression reference root self. That's going to return something, and it's going to do something. Works at the moment. Need to bring all this stuff back in slowly. Code block. Anything greater equals. Oh, there you go. Oh no. Actually, you know what? We can put it out there if we have to. Sign. Oh, no one there. It's not a bang anymore, it's a logical not, which also has logical and logical or. That'll be fine. Bitwise and bitwise or. Bitwise and bitwise or. otherwise not. Appears not. Close braces, semicolons, divide, else. Function cool, but not function def. Function def. Identifier, semicolon, semicolon not equals. No, not equals. Okay, that's all we formatted. It's not T type anymore, that's node type. And we have so if data, we have to fill out all the rest of those in a minute. Binary T data return boom boom boom. Just gonna want if data in there. And we're going to have to do the others in a minute. Finally, not a struct. We'll go with AST node. Node type. Node data. That's good. And what else we got down here for my thinking? That's us playing it one way or the other, wasn't it? Which I think we're doing it this way at the moment. I did think we could reason why. Ah, yes, because at some point I may want to add a something like that, which might be optional, might be a box. Optional box. Something like that, but we don't have it at the moment, so I wouldn't want to go in and have an enum and keep having to add all those, because initially this would be empty. And then it would turn into initially none, and then it would turn into some, and then info there. Not sure where I need that. Not so good at type systems, so we should endeavour to read about them. That is that. Excuse me. Yep. Next question is, what's going on next? We want to do parsing, but we can't until we've done the structs. Struct. Get data. figure that out at some point. And initial XPR stock. Type is not happy with that, so let's go with. Well, why do we keep putting a code up there? So language can have a letters. Let my I just thinking in my head you could do uninitial and to break British spelling, uninitialized. My type. And then this we could highlight in red. But what's more likely is we do only because uninitialised is pretty hard to time, so people will want to do it so they actually think about how to initialise things. But currently, it needs to be a copy. Code block. Again, because in theory it could have a return type. If it's an expression, we shall code block. Data. Why statements? Why am I calling it top all the time? That should be no, shouldn't it? Have I got a dock here? Good. What I'm doing at the moment is just creating a collection of data structures that will store what I need. Documents, and technically it doesn't have to be names, so could be all it's do is resolve to a function that we can call. So it could be a function pointer, it could be a lookup out of a map that returns some type of callable object. Right, and finally, name for a code block. Keep things as uniform as possible, and as many allocations as we possibly can, and I always feel like this takes ages, but in reality, in the time you spend doing other stuff, it does not. I can't remember how to do debug. Here you go. No. Right, who's getting annoyed with box aliasing types on Rust? How does that work? Rust type alias. Type. Cool. I was going to create a PAST node or just P node or something, a pointer to a node. But I've done not too bad. Right, rat parsing. So we've got a parser, and we're going to need a trait. Trying to work out how to set up an object inheritance here now. Unary expr, and then we've got -expr, mute parser token. That didn't work. Seemed to. And now I'm going to talk. And I'm going to try and explain this, even though I'm not sure I know how to explain it. Box AST node. And it takes ownership of it, so we can have it like that. And what are we going to do? We're going to call that HS, the left hand side. How's best to do it? Wait, any expression. This is a brief nearly any expression, many expressions, all expressions, many expressions. When you've got an expression, let's say you've got 90 plus 100, right? 100 times 10. Alexa comes here, it gives you this. And it says, well, you're 90, you're a number. That's cool. And then when you pass an expression, you oscillate between a binary expression and a unary expression. So in this case, we move our cursor along. How do I? Probably with that. Is that working? Yep. Going along. Ooh, lucky. We hit this minus. We've not got anything before it, so we're like, well, new unary thing. So we then say, okay, hit unary minus. We look up how to do that. He says, oh, you just parse an expression. And he goes, okay. Got 90. Yeah, that's a number. Ooh, next thing, no, not a plus, because that would have a higher precedence. Therefore, it returns 90, and they create a unary node of that. We then fall through, and it's like, right, we just had a unary node, so therefore we must have a binary node. Because, yes, you're a plus. What do we know about that? Well, plus has a binary node. Therefore, we must have an expression on the right hand side. We've already worked out the left hand side, so we parse it, and we get 100 back. We are happy. We now have something like plus minus, let's create a u minus. And on this side, using my awesome art skills, we have 100. It goes, okay. Oh no, something's gone wrong. This binds tighter, so let's get to precedence later, but we have a way of fixing this, so we actually end up with binary, but there's a sub-expression going on. Let's get rid of that. 100. So the key thing is that we have an oscillation between unary operators and binary operators. Remember here, there is an implicit plus here. So it goes unary operator, gets a 90, creates a unary node, and then falls through, says, oh yeah, I know a plus operator. That's the binary. Goes along here, says pass in the unary expression. Well, there you can do that. And it's implicit plus, but we actually end up putting identifiers as unary operators, and they just return themselves, so they're a unary identity operator. Maybe not. Maybe this is very badly explained, but we get to it. We're going to try doing unary operators first, and then we're going to move on to doing binary operators, and then finally we'll start the precedence. We'll do unary operators, as I said. Somewhere in the middle of that we're going to need some pretty printing, so we can start looking at the precedence and stuff, and to make sure we get things right, because obviously if we've got a times 10 here, 100, when we do the plus, this is the sub-expression we want to evaluate first. We don't want to do minus 90 plus 100 times 10 to make 100. What we want to do is 100 times 10 to make 1000 minus 90, which makes 910. Two different answers, so we want to evaluate it like that. Remember your elementary algebra? It's not even algebra. Numbers? Pod maths? I don't know, I can't remember what the kids call it these days. Precedence. When you learn your precedence operators. That is where we're going. I'm half tempted to call it at night. I'm also half tempted to try and mess around. And, oh hey. Hey there, I am trying to code a pract parser, which I shall dig out a link. parser tutorial, because I'm not doing a good explanation of explaining it. Not you, not you. This person does a very good introduction to it. Not amazing, I'm also not very good at Rust, so I'm really struggling on that. I'm just trying to figure out some inheritance style setup, and that's where I'm heading. Does that explain what I'm doing? There's not much going on really. And, I'm about to call it a night. That is it. This will do a much better explanation than what I'm going to do. You're probably going to see me struggle next time I code. And that's the question on the stream. Actually, I suppose I've got a question, to be honest, so thank you very much. Looking that way, because that's where my second monitor is, where the questions are. Thank you. God, I'm terrible at explaining stuff. I'm really sorry. There we go. So what we're going to do is... we're going to create a... You know what, I'm not sure we actually need traits for this. They don't store any states, so we're not going to need a struct, so we're not going to need to inherit from them. What we're probably going to need is just straightforward functions. So we're going to want to do a minus. And then we're going to want to fill in a uni plus. There's going to be some other unary operators. This is going to return box node for now. St node. That's heading along with some errors. Not error handling, but I'll probably factor that in later once I figure it out. And as we said, identifier is going to be another, and string. Yeah, we're calling it that. String HO. And number. That's pretty good going now. So we've got unary minus, unary plus, identifier, string literals, and numbers. So we're classifying all these as unary operators. That is, we get the token, which we're matched, and we get the parser, so we can do things if we need to. So in the case of a number, what would we need to do? We would need to AST node. We're going to need to return a number. So what are we doing? Return box new AST node AST node, and then we can do token dot my number type is That's a bit of a weird one. $102. Second payment, that's 60 box new. That's all very well, but that's not the error, is it? And now I struggle. Let's comment them out because we put those back in later. Just want to do one. Recent token, take a token, right. Let's go to that. Data. Ooh, interesting. We haven't got no data for a few things, have we? String number identifier. So we got text. Oh god. Parse. 32, we get away with that? Nope, don't know how to do that. Rust parse string to keep from str. No, it's not. Well, not because there's no way I can't think we've got a decimal point, but at the moment we only match numbers, so. And finally, node type number. So what's good about this? Well, let's see what complaints we got now. Unexpected type argument. True. Okay. So on parsing, whenever we hit a number, we're going to we'll discuss how to look it up later on. It's going to involve a map. We will call this function, and what it would do is it take the token number, the lexical token that contains information about a number, and it should just translate it into an AST node along with an application to put it into a box. So in some ways this is really just an identity. Nothing changes, we don't do anything special. Okay, it does change because it changes its type, but it's really, you know, a one-for-one translation. There's no magic going on in here. We don't need a parser. And when we next code, we shall fill in the others, but I'm going to get this merged in, and we shall then be able to continue. God, I've been coding for an hour, so I think I'm going to call that a night. Go watch a bit of Ozark. I think we've been ploughing through. It's in good position. I'm not going to guarantee when I'm going to stream next, but this will be the next things we do. I might do them off stream. And we do the more interesting, difficult stuff of the actual expression parser, expression later on. Yeah, I'm quite happy with tonight. We have coded a lot to figure out modules and different files so I can get rid of the Lexa stuff. Do its own module. Don't think it's that hard, I did it before. And yeah, all this is hopefully fairly simple, but I don't know. Anyway, end of that. Time for me to go do some other stuff. Maybe tomorrow we will code some more. Right, thank you for watching. Go to end the stream.